Assalamu alaikum, dear students. I'm Mr. FAYAZ KUCHAY from Baramallah. I'm being posted at Ashpura Higher Secondary, Kupwara. Today I may discuss about Faraday's laws of electromagnetic induction for class 11th. Let me give you introduction about Faraday's laws. Faraday was a scientist who gave two laws for electromagnetic induction. The first law he states as, this law states that when a conductor are placed in a varying magnetic field, EMF are induced, which is called induced EMF. Let me tell you, beta, where there is magnet, there is a magnet having polarity as north-south pole. Where there is magnet, there is magnetic field being created by a particular magnet around it. So when we talk about the magnetic field altogether, that's known as magnetic flux, the power of magnetic field. So similarly, when we place a magnet near a conductor, conductor simply means that material which makes current to pass through. When we place a magnet near a conductor, we say, the Faraday says, there is magnetic field. With the help of magnetic field, an electromotive force is being created in the conductor, and electromotive force is induced, which in turn is known as induced EMF. And if the conductor is closed, that means there is no leakage in the conductor, it's not open, it's closed, then it produces induced current also. And this was the Faraday's first law, which is stated as, I may tell you again, when a magnet is placed nearer to the conductor, a magnetic field created by the magnet will make induced EMF produced in the conductor, which in turn is known as induced EMF. And if the semiconductor circuit is closed, then induced current is also being produced over there. This was the Faraday's first law, which he states, which I have already written here, what he states, how he discusses about the first law. So dear students, I'm sure that you may have got it, you may have understood what the Faraday's first law was. Now the Faraday's second law. In second law he states that the induced EMF, now this induced EMF, when this induced EMF created by a conductor, that is directly, he says that it is directly proportional to the magnetic flux with respect to the time. Magnetic flux, where E, mathematically we can write E, electromotive force, EMF is proportional to d phi by dt, where this d phi by dt is magnetic flux with respect to time. So E is electromotive force is equal to minus k d phi by dt, where k is constant, magnetic constant, E is equal to EMF, where E is here given its EMF, electromotive force, and K we are taking at a stage a constant, K is called constant, then the relation becomes E is equal to d phi by dt minus times so electromotive force is equal to minus times d phi by dt. d phi I have told, d phi is the magnetic flux with respect to time, dt with respect to time. So in the second law he says, Faraday says that electromotive force is directly proportional to d phi magnetic flux with respect to time, dt, or we can say E is equal to minus k d phi by dt. Why are k is constant? We are placing it k is equal to 1. So E is equal to minus d phi by dt. This will be equal to d phi by dt, where k is equal to, I may write here, k is equal to 1 as per SI unit. It is taken to be constant. K is equal to, its value is equal to 1. So we will have electromotive force is equal to minus times d phi by dt. But here the point is, why is it minus times? This is minus times being given by Lenz's law, which is related with Faraday's law. Lenz's law, I may give you a hint about Lenz's law. Lenz was another scientist who said that Faraday's laws were given, but Faraday could not explain the particular direction of the current, the direction in which direction current could move. That's why Lenz gave his own formula. In which he described the direction of the current. That will be discussed in the second lecture. Okay, that will do for today. Assalamu alaikum.